But no one is guessing. Students have studied.
Yeah.
So the underlying process that is generating these MCQ cards, if you like, the MCQ
It's not random.
It's not random.
Yeah.
And you could come up with a mechanism for how people are filling their cards in, and I could come up with a mechanism, and they're not going to be the same. And now who's to argue? You can't answer that question just by looking at numbers.
Yeah.
So eventually it does come down to these sort of softer elements.
Yeah.
But I mean, that's a diversion, but it was an interesting non-standard topic. Eventually we kind of solved it out by looking at kind of a combinatorial solution, looking at all possible pairs and looking at how far apart they were, like a distance metric in each individual response, which was quite a fun exercise. And in the end, they didn't use any of that, because when it goes to the legal case, what was most important is they had an invigilator who had watched them. The invigilator gave evidence and had seen them exchanging things. So the stat stuff wasn't really necessary.
Yeah. But interesting, I mean, I know that you've done a bit of stats work also in the comrade space.
Yes.
I know you're an avid runner.
Yes.
I remember that even from when you lectured. You're always talking about running. And you did a bit of research in the comrade space also to do with GSAM, is that correct?
Also, yes. And
Seems to be a trend.
It is a bit of a trend. And this is, I mean, it's a really good topic, I think. The way that happened, I was curious, interested in a really simple question. Just a trivial, so at Comrades I was interested in, do people run the second half of the race faster or slower than the first half of the race?
And you would think that they would run it slower. And by slower
because it's tiring. Exactly.
But I guess it also depends if it's up or down the hill.
Absolutely, yes. But again, the same sort of thing, you could separate out by those, whether it's an up race or down race.
100%, so you could filter.
But then the next question was, if people do slow, how much are they slowing by? So almost thinking of a kind of a distribution of the second half times versus the first
like a decay.
Precisely.
Yeah.
So that's all I wanted to answer. I got a hold of some data of the time that people reached halfway and the time that people finished the race, and a simple subtraction. You get the first difference, the second difference, and I thought I'll plot it on a scatter plot.
Yeah.
And that will give me some idea of any kind of relationship.
Yeah.
And when I plotted it, there's a whole bunch of points, more or less where you would expect them to be, and there were a few points way off on
like
the
outliers. Okay.
And when you looked at the outliers a little bit more closely, I suddenly realized that some of those outliers involved people covering the second half of the race up to an hour or 2 hours faster than the first half of the race.
Which just makes no sense.
Which seems, a priori you thinking, this is a very strange way. This means that they ran really slowly to halfway, and then they sped up and went crazy to the finish.
Yeah, they got a new set in legs in the second.
Which again could happen. Maybe they're running with a friend, and the friend gets tired and stops, and then decide,
okay.
So plausible explanation. But then when I started looking at it a little bit more closely, I realized that for some of these people, they were missing intermediate points on the race.
Okay.
And when they missed those intermediate points, the speed they were running at, or allegedly the distance, the time that they covered the distance that they should have covered, was much too quick. Like running faster than the world record for...
Like Usain Bolt.
Exactly. Like it was just simply implausible that sort of amateur runners would be running at those paces. So again, a natural question uncovered this sort of cheating behavior, this bad behavior. And I can imagine in an actuarial sense, for people working, say, at an insurer...
Yes, be fraudulent. Slaves. Yes,
it's a huge thing. And especially nowadays with a lot of things being done more online.
Exactly.
There's a huge market for insurers now where you don't necessarily go into an assessment center or anything. You take like pictures of whatever you're insuring, and there's massive scope for fraud there. I could easily spend the rest of my days sitting with those data sets, just asking natural questions, not asking, is this person acting in a fraudulent way or in a suspicious way? Just asking natural questions. What is the distribution of claims for this particular category?
Yeah.
What other covariates, what other characteristics are there of people who make these kinds of claims?
Yeah.
You could probably build up a risk model for fraud just on a single insurer's claim experience.
Yeah.
I think that would be super interesting.
Yeah.
I don't know if they would ever have time for things like that. But I mean, that's the kind of thing. I mean, a related question is, how do you get better at statistics? How do you improve your statistical skill set? If I was working at an insurer, I would do like my day job of whatever I need to be doing, pricing or strategy, whatever the case might be. And in the evenings or over weekends, if they would give me access to that kind of data, that's what I was doing.
Yeah.
Build some models, play around with different techniques and ideas, learn.
See what stories kind of emerge.
See, and it really is that. You've got exactly the right idea there. It's a story that comes out of it. And it starts with a bunch of data, a whole bunch of numbers. And when you start to sort of dice it a bit and look at it from different angles, you start to notice patterns.
Yeah.
And I think a great deal of any kind of quantitative work is exactly that, noticing patterns.
Yeah.
And I think the best way to do that is to actually do it.
Yeah.
People sometimes say, well, how will I notice a pattern? Just do it. Trust
Yeah,
us.
and once you start, I remember when I worked in corporate, and you would start seeing the beginning of a story, and you'd be like, "Oh, I want to know where this goes," and then you dig a little bit deeper, and then you'd be like, "Okay, wait, the story's changing," and like it is very interesting the stories that data can tell you.
Completely. And I think learning is the same. When you start in first year, I think when most people come out of school, when they still have a kind of school-based mindset of how they learn.
Yeah.
That studying must be, I must make notes and I must put it in a file and memorize these things and then go over it 10 times. Those aren't bad things to do, but it's also a good idea to try and start noticing the story. There's a pattern in what you're being taught. You're not being taught random, here's a random fact and there's another random disassociated fact.
Yeah.
There is a pattern to all of that. And it might take a couple of years for you to see a bit more of the landscape of that pattern. But in my mind, it's the exact same thing. You're looking for the story that connects all these bits and pieces together. Mm. And maybe that it might even take years. Maybe even once you start working, you might only start connecting the dots.
Yeah.
Oh, that's why we had to take care of a particular constraint or be aware of a certain difficulty with using a certain technical method.
Yeah.
These are... Yeah, I often find it interesting how things kind of parallel. The learning of a subject and the application of a subject and even the teaching of a subject.
Yeah.
They sort of follow the same rhythms. Yeah. And there's a lot to be learned from that, I think.
I think it's interesting you say that because I've just come into the academic space. I started at UCT in January of this year.
Thanks.
And although I was working at a school for 2 years prior, as I was teaching maths. And it's very interesting for me how my understanding of the content has changed, having to now teach it. And I don't know, has that been the case for you as well?
Absolutely. As a short diversion, often students ask me how to study or prepare for exams. And one of I really think this is probably the most considered piece of advice I can give, is if you can teach what you need to learn for the exam to someone else, then you understand it. Yeah. And if you can't teach it, and really teach it, not just
like
record it, exactly verbatim, just read a script. If you can explain to a friend, even if it's an imaginary friend, then you can really say that you've understood it. And it sounds like quite pithy advice, like, and how am I supposed to actually do that, But it is fundamentally, I think, the best way to assess my own personal understanding. Your original question, without doubt, when I started teaching, it actually was ridiculous that I was teaching statistics with such a bad understanding of how it all fits it together.
Yeah.
I only really started to see the landscape when I needed to teach it.
Yeah.
Which is inevitable because in order to teach something, you can't only know that one thing.
Yeah.
You have to know the 10 things that surround that one thing.
Yeah.
So that if someone asks something about it, you're not just saying, just trust me.
Yeah.
It's this. You can explain. And people appreciate, especially most of the people that study, say, actuarial science, they're not silly people. They've got there because they can notice patterns. They're looking for patterns.
Yeah.
And the best way to explain something to someone who has that mindset is to show them the sequence of links that make the pattern.
Yeah, it's all about connection. Yeah.
And as soon as they see that, it's so much easier. It becomes natural.
Yeah.
You're not trying to memorize something. I'm glad that you had a similar experience teaching. I almost wonder if it's not kind of a prerequisite for a level of expertise is to spend some time teaching or mentoring.
Yes.
I haven't spent any time in corporate myself, but I imagine there's a fair component of it where you do need to mentor people to get them to a certain skill level.
Yeah.
If you think of the medical profession, there's a strong tradition of doctors teaching the next generation of doctors.
Yes.
And I think that it's not just about teaching the skills. In order to teach, you have to develop your own skill set.
Yeah.
So I think that's definitely the case.
I think another thing that's been really interesting for me is also understanding the misconceptions. And I think a big part of teaching, especially when it comes to technical work, is understanding where those misconceptions come from and almost addressing them preemptively.
Yes.
And also realizing where your own misconceptions are. So that's been very interesting. I sometimes look back and I'm like, how on earth did I pass statistics? Because there's many aspects that I was like, I was just learning the recipe. And then now I'm like, oh, okay, I understand.
That's what it meant, yes. I've looked back, and I think earlier this year I found one of my old third-year test scripts. And I thought, this will be interesting.
As one does.
Yes. And it's ridiculous. I still have that.
Yeah,
Years ago. But so I opened the first page, and the first line I looked at, I said, that's wrong. It was something about a covariance of a matrix or something.
Yeah.
But just what had been written, I thought, I can't believe that's the very first thing I heard.
Yeah.
When I look at it now, I'd say, this person has no idea what they're doing.
Yeah.
And it's my own handwriting. So I think that is, it's very interesting to deal with these misconceptions. I'm curious, have you ever considered, I vacillate about this every year, whether I should point out a common misconception to a group of students in the hope that they will notice the misconception. And then we talk through why is this a mistake and what's the fault in the reasoning, or whether to not mention it at all in case my mentioning it makes some of them adopt the misconception.
Sure.
Because it's always happened to me in years where I've shown, where I've done this, I've pointed out, be very careful about this misconception.
Yes. And in the test, it's like,
yes. It's like in perfect, absolute, like verbatim, it's covered the same misconception. And I'm curious, like, I can't tell if it's for different students. Some students receive that better, and other students almost don't show me stuff that's wrong.
Yeah.
But I don't want to see that at all, please, because it's just going to throw me off.
Yeah.
And I can't yet tell whether that's for different people or just...
Yeah, it's a very interesting question. I don't think I necessarily have that waxed, but I often tend to like ask a question in the sense that I want them to interpret what they've done. And so it's like, okay, so you're doing this, but like, why are you doing this? And the thing is, I think if you understand that, the misconception falls away because you understand what it is that you're doing. So I was teaching runoff triangles the other day, and I said to them, why do we use increments as opposed to cumulative factors? And they didn't know why. And I was like, well, then how can you use this? Like, how can you, why don't we use one or the other, And I think there is a misconception there, but instead of saying, okay, this is a misconception, saying, okay, why do we do it this way?
Yes.
So I don't know if that's necessarily right, but that is sort of how I've tried to relay it.
But that's the exact, that's kind of the approach that students must take with everything. Honestly, everything. Anything that a lecturer tells you. If you get told, we're going to now differentiate this function to find an optimum. Why are we going to differentiate? Just because I've learned calculus, why must I use the derivative? Is there another way to do this?
Yes.
Why is
doing that way?
Yes, and why is it doing this way the best way? I think it comes back again to the sort of mindset that you have when you're receiving information. You have to be quite inquisitive. And it's not being disrespectful in any way. It's more just, like you've just said, trying to connect. Why are we doing it this way and not that way?
Yeah.
Sometimes that's the best kind of question someone can come to you. If a student comes to you and says, okay, so I've solved this problem, And I got the answer by doing it this way, which always makes me feel like, oh, no, they're just worrying about the answer.
Yes.
But then they say,